Hello and welcome to part 2 of lesson number 7 in Unit 2B, Quadratic Functions, Forms, and Transformations in our grade 11 University College math class. This is quadratic functions comparing three forms. So in the first half of this lesson, we looked at a new form that we haven't looked at yet in our grade 11 class, and that is factored form. We talked a little bit about how to take pieces of information from it and then produce a graph. The most important piece, or the most obvious piece of information, are the x-intercepts. They're the opposite of how they appear in the brackets. Once you've got your x-intercepts, you can either visually or algebraically find the h component of the vertex, which is the x part. You then substitute that back into the original equation and it will give you the y component. Then you go about graphing using the plot pattern, which is the a value, also provided in factored form, and then off you go. Do your labels, and you're good. Vertex form. We've already spent a whole unit on that pretty much, so we're not going to talk anything about vertex form. Now we're going to jump to standard form. Now standard form is, I think you'll find, like the least effective one when it comes to graphing, or the least productive one. So let's jump right in, because who doesn't want to start with the least effective one? So we have f at x equals x squared minus 2x minus 8. So for us, remember that our parent function, or I guess the bare bones version of this one, is ax squared plus bx plus c. The piece of information that we get from standard form is going to be the y-intercept. And the y-intercept corresponds to the point 0, c. And c is the constant value at the end of our of the standard form quadratic. So in this case, our y-intercept is going to be 0, -8. So that's a point that we can pop on the graph. And let's do that right now. So if we have 0, -8, that's going to be down here. What you'll notice right off the bat is that's not very helpful. There's no companion point to it, so it's not easy to find the vertex. It's a bit of a drag. It's not the most useful form, as you can see. But there is other pieces of information we can get from this form, including the a value. The a value shows up in front of the quadratic term. So our a value is equal to 1, which means that our plot pattern of 1, 4, 9 will be amplified by a, which means that from the vertex we go out 1, up 1, out 2, up 4, out 3, up 9. So no changes there. So how do we go about, and we know that our direction of opening is going to be up. So how do we go about acquiring the vertex? Honestly, you would probably try a table of values at this point if you weren't 100% sure how to do it. But there is what I'd like to call like a cheat method. And the cheat method is this. Similar to the way that there was a formula to figure out the h value from factored form, there is a cheat way to find the h value from standard form. And the cheat value is to find the -2, or the negative b value, negative b over 2a. And of course I'll be using the a, b, and c values provided in the quadratic that we're using. So our negative b value is going to be negative 2 over 2 a's, which is 1. So minus 2 gives us 2 over 2, which gives us 1. From here we can figure out what f at 1 is equal to get the vertex. So that's going to be 1 squared minus 2 times 1 minus 8. Let's work our way down the line. That'll be 1 minus 2 minus 8. And that's going to give us -9, or 1 minus 10, which will give us -9. So our vertex then is going to be 1, -9. So short of doing a table of values, this is the most effective way to quickly find what the x and y components of the vertex will be. So let's get that on the graph. That's 1, -9, so there we go. That is our vertex. So let's sketch through our axis of symmetry. Axis of symmetry, top to bottom, sketched through. There we go. And that we will label x equals 1. From the vertex, we can get back to labeling the points on our graph. So from the vertex, out 1 and up 1. And we already have the y-intercept on there, which is good. Out 2, up 4. 1, 2, 3, 4. And then 9, which is up here. Let's sketch our graph out. Keep it as curvy as possible. Get some arrows on there. And let's start labeling. Label the vertex as always, 1, -9. Again, in this case, we actually have 3 points that we're going to be labeling because we have both a y-intercept and 2 x-intercepts to label. The x-intercepts being -2, 0, and 4, 0. And then we label the function. So f at x equals x squared plus 2x minus 8, I think it was, minus 2x minus 8. Minus 2x. All right, so there you go. What you'll notice at this point in the lesson is that we have just graphed the same identical graph 3 times from 3 different forms. And this is not uncommon when you're working with quadratics, as you have different ways of expressing the same thing. Factored form, vertex form, and standard form all give you particular pieces of information, but they can be representing the same relationship, just articulated in different ways. So that is the beginning of our note. Over here, there is a fairly substantial summary of the information that you can get from each of the 3 forms. Now, I'm not going to write it out because it's a lot of writing for me to do while you just watch me write. So this would be a decent time to pause in your notes and just say, all right, make a little section. This is what you get from factored form. On the left, you see we have a substantial graph, and we've just used the letters to articulate what pieces of information the different forms give you. So starting with factored form, you have the A value, which tells you the direction of opening and whether or not there's a vertical expansion or compression. Another way of saying that is that you have the plot pattern. In factored form, we also have R and S, which correspond to the x-intercepts. Another word for that is the roots. And the x-intercepts are R0 and S0. You can see them there on our sketch on the left. Vertex form, pretty straightforward. We have the A value, which tells us the direction of opening, as well as the plot pattern, which is whether there's any vertical expansion or compression. We also have H and K, and they correspond to the X and Y components of the vertex. That one we should be pretty familiar with. Standard form, our final one, we get the A value, which tells you the direction of opening and whether or not there's a vertical expansion or compression, also known as the plot pattern. And the C value tells you the y-coordinate of the y-intercept. So 0C would give you the y-intercept. So what do all 3 forms have in common? Again, usually we do this in class and there's a fairly substantial list, but the big one is going to be the A value. All 3 forms have the A value. They give you the direction of opening and the plot pattern. Other things that people say are they're all quadratics, blah, 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 that kind of stuff. The most important thing that you want to know is that all 3 forms tell you the direction of opening and the plot pattern. That's the piece that takes you the rest of the way that you need to go. Sometimes people say like there's ways to get the vertex from all 3 forms, and that's true also. So this was our first lesson in Unit 2B forms. We've just looked at different pieces of information that the 3 forms give you, and the remainder of our unit will be spent working how do we get from one form of a quadratic to another. And then we're going to tackle some word problems using the particular attributes of each form of the quadratic to provide us with guidance as to what piece of information the word problem is asking for. So that's a little bit of a preview of what's coming. Good luck with the homework. If you have any questions, reach out in person, reach out via email, come to our online video chat that's open daily. We'll get you sorted out. Good luck with the homework, and we'll see you in lesson number 8.